In this video, we are going to complete part 2 of the ModFlow conceptual model approach sequence of tutorials. And in the first tutorial, we build a simple one-layer model, constant value of K, constant top and bottom elevations, and we use general head boundary conditions for the river on the bottom and up the right side of the model. In this tutorial, we are going to add recharge, very important part of the model input. Then we are going to create these two wells shown here. And finally, we are going to create these three arcs right here and turn and make them drains. They're meant to simulate creek beds that will only flow if the water table intersects those creek beds. And so those are basically some additional sources and sinks that we'll be adding to our model. And so once again, there's a set of instructions and some a set of files that you need to download to get started here. I've already downloaded and unzipped those files from the Alcoveo website. And we'll go in here, and this is in the modfmap2. And we're going to read the start.gpr file. And it's very similar to, it should be pretty much identical to what we stopped with, or to what we ended with last time. And so I'm going to do file save as. I'm going to save this under a new name to map out our changes here. Instead of using start.gpr, I'm going to do easttext2.gpr. And okay, the first thing we're going to do is we're going to create a recharge polygon. And to do that, I'm going to right-click on the boundary polygon and select duplicate. And I'm going to double-click on that and call this recharge and turn on a recharge rate and click OK. We turn off that background layer for a second. And I don't need to see the grid frame. So this is our recharge coverage, and I need to do build polygons under the feature objects menu. And now I can use the select polygon tool, double click on that, and I can enter a recharge rate of 0.0003. And this was found by taking 0.75 meters of rainfall a year, multiplying it by 0.05, assuming 5% of this gets to the aquifer as a result of recharge, and then dividing that by 365 to get it to a daily rate of meters per day. Okay, and so that defines our recharge, so I'll save that. And at this point, we can go up here and say map to ModFlow to copy those changes over to our ModFlow grid. And so now if we come in here to recharge, let's see, excuse me, wrong, I'm going to double click on my recharge coverage here, or array, excuse me, and I'll see that 0.03 value has been assigned. And let's check simulation, see if we're good to go. Everything looks good. We'll save our changes and run. And now we should have a little bit different solution. We still get some water coming in from these two ends and exiting here, but our flow budget should be different now. We now have quite a bit of water coming in as recharge, a lot more water than we had coming in before. And some of that, and for these rivers, some water is going into the aquifer and some is coming out. So we have a balanced flow budget once again. And so now we are ready to go to the next step, which is to create two wells. Now there's a well over here and a well on the right-hand side. There's nothing on the map, the background map, that can tell us where to create these wells. So we're going to create them and then use the coordinates of the wells to specify where they should be located. Okay, so before we create the wells, we're going to create a well coverage, and we don't need to copy the boundary coverage because all this is going to have in it is 2 points. So I'm just going to say new coverage. We'll call it wells, and we'll turn on just your normal garden variety wells. Turn off this model area toggle. We don't need that here. And okay, now I'm going to use the create point tool, and I'm going to click over here somewhere. And now, if you go to the tutorial, let me drag this onto the screen here really quick. It has a, whoops, sorry, that expanded here. It has the coordinates for these two wells, and so I'm going to cheat a little bit, and I'm going to copy those coordinates using the clipboard from the PDF file. And whoops, now that this well is created, if I select it, I can go up here and just type in these coordinates in this window up at the top for the X and Y, the latitude, longitude, and I can put in an elevation if I want, although that doesn't really matter. And then I'm going to create another one right over here, and then while that is still selected, I'm going to enter another set of coordinates for that. And here's the Y coordinate, and 213 for Z. And another way I can get at these two wells, if I select them and then bring up the attribute table and do show coordinates, you can edit the coordinates here as well. And now I'm going to call these wells. This is going to be well 1, and this is going to be well 2. And then the pumping rate for well 1, let's see, minus 50. It's just a very small well. It's in meters cubed per day, so this would be the average pumping rate. This one's minus 300. And so now we have our wells defined. Let me turn off that background image here. Let's see, wrong one. So turn that off, and now you can see those two wells defined here. And again, we're kind of building this model in increments. So if we say map to mod flow, that should create the models on our, or the wells as part of our mod flow input, and we can save and run. And now we should see in our solution, you'll see a little cone of depression there, very minor impact over here. If we look at the flow budget, you should see the wells now minus 350, 50 for one, 300 for the other, and that all looks great. Turn our background image back on. And now we're ready to go to the next part where, let me turn the grid off for a second, but if you look in this background image, there's a little ravine here, there's one here, and then a slight ravine right here that correspond to these little drainage areas, and we're going to represent them using drains. And to do that, we could copy our boundary coverage and digitize those lines, but we're going to cheat a little bit, and we are going to import a predefined coverage for us, drains.map. It's part of your input here. You might have to change your filter to say all files, and that brings in a coverage, drain arcs. Here we go. Actually, it's a separate conceptual model here, but that should have. But so this imports as a separate map conceptual model object, and I want this to be part of my conceptual model. So if I just drag that up here, and you know, then I can delete this other one down here, and so now I have these drains as part of my conceptual model. And so the next thing I want to do is I want to select these three arcs. I'm going to hold down the shift key, and I'm going to say attribute table, mark those as drains. Now I need to enter coverage, and this is a conductance per unit length, and I'm going to do 555. And in this case, the calculations are described in the tutorial, but again, it's a conductance per unit length like we discussed in the previous video. The hydraulic conductivity is 12 meters per day. The drain width is average about 9 meters, and the flow length, vertical flow length, is about 2 meters. So this gives a conductance of 555 cubic meters or square meters per day, per foot, or excuse me, per meter. And it's kind of a high value, but that's okay. That just means there will be not a lot of resistance to flow between the aquifer and the drain material. So click OK, and that's part of it. Doing a drain is a two-step process. So we've marked these as drain arcs, and we've entered a conductance, but now we need to enter elevations at the two ends of each of these arcs, and so that the drain elevation will vary along the length of the arc. And those elevations for each of those are given in the tutorial. So I'm just going to use that as a guide here. And we're going to start over here. And this one is 221. And number 2 here is 212. These are all meters above sea level. And over here we have node number 3, that is 220. And number 4 would be 211. And number 5 would be 221. And right here for number 6 we have 210. Alright, so there are drain elevations, and we'll save our changes. We'll do map to mod flow again to copy over this latest set of changes that we made. Let's turn our grid back on, turn our background back on, and then let's do check simulation just to make sure everything copied over all right. That looks good. So we'll do we'll run mod flow now, and there we have our solution. It doesn't look much different. Let's go into the flow budget, see if those drains made any difference. I mean, it's always possible. Now look at this, 0, 0. So okay, we went to the effort to put drains in, but the elevations are such that the water table is below the elevation of the drain, so they ended up not having an impact. Now, I guess we wouldn't know that until we run it, and we may make changes to the model later that would change those results, but anyway, that's kind of how it shakes out there. So there you go. This completes this part 2 of the conceptual model approach tutorial, and we'll wrap that up and come back with part 3.